Right, now I'm going to teach you about the coolest feature of lists in Python. And this is just an example of why we love Python, because Python has this beautiful thing called list comprehension. Very often you don't learn about this kind of thing until a little bit later in a Python course. It is too beautiful to ignore, so it's a little bit more complicated, but I think there's a lot of value in learning this early, because you will find them so nice. Now, they don't give you any functionality that you can't do without them. They are just a really elegant shortcut, and computationally they are much more efficient if you're particularly working with larger structures. Okay, so what a list comprehension is it allows you to create a list that is based off another list, and in some way, and it does so using just one line of code, and in a very beautiful way. So let's think about an example, because that sounds a bit abstract. Let's imagine we've got a list of numbers here. I've called list A, just contains the numbers 1, 2, 3, 4, and 5. Let's imagine I think, okay, I need a second list now, which is all the numbers of the first list but doubled. That's what I want. Now, one way you could do that, using everything I've shown you so far, you could write that. You could use a for loop. You could say, okay, well, for each number in list A, then append to list B that number multiplied by 2. Okay, so I've taught you enough to be able to, you could write that, and that would be fine. That's valid Python syntax, but it's not very efficient to do that computationally. It wouldn't matter for something like this. But if you were doing something a bit more complicated, you can start to notice it's not quite as computationally efficient. So a list comprehension, we've got 3 lines of code here. Ignore list A, because that's set up. We've got 3 lines of code here to create list B. We've got the create an empty list, and then the declaration of the for loop, and then basically to append that the number doubled. And some people may even put a 4th line where they would double the number first and then append that number. A list comprehension will do all of those 3 lines in 1 line of code, and this will do exactly the same as above. Okay, so what this is saying, and it's easier often to read these things from the middle, is it says for every number in list A, give me back that number doubled. So give me number times 2 for each number in list A. There you go, done. Put some square brackets around it. That's a list comprehension. That will very efficiently create a list B with 2, 4, 6, 8, 10. And it'll give you exactly the same as up here, but much more efficiently. And as I say, it tends to, you may find it varies, but I tend to find them easier, and I tend to recommend reading them from the 4-bit, because you can then read the bit on the left last. So for each number in list A, give me number times 2. Okay. Now, there's all sorts of other things that we can do in a list comprehension as well. We can also add in conditional logic. So that allows us to create a list that contains all the elements in another list that meet a certain criterion. So imagine we've got list A here, which is just the numbers 1 to 10. Let's say that we only want to, I was about to give you the answer. So, well, no, I will give the answer. So let's imagine we only wanted even numbers from our list. Okay. What we could write is this line of code here. And this would create, using a list comprehension, a second list that only contains the numbers 2, 4, 6, 8, and 10. Because what it's doing here, again, start reading from the 4-bit, says for every number in list A, if the number modulus 2 is 0, in other words, if it's equally divisible by 2, which means it's an even number, then give me that number. Okay, for each number in list A, if the number modulus 2 is 0, give me that number. Otherwise, it will ignore it. So that will create a second list that just contains even numbers. 1 line of code. Beautiful.